Okay, so putting transformations all together for this warm-up graph here. I know normally I'd have you graph these and we'd go through it all, but obviously I can't have you do it. So the first thing that I would look for always when I'm graphing is the over and up chart. And I'm going to notice that 3 of these are this one. Let's use some color here. This one and this one. Oh, oopsie doodle. Let's just move that up there. These 3, so the first 2 and the last one, all have the same over and up chart. So we're going to be going over 1, up 1, over 2, up 4, over 3, up 9. Now I'm not actually going to graph these. What I'll do is I'll just put in the vertex and then I'll put the point pattern in for each one here. So y equals x squared. You guys should be able to do this one in your sleep. So that one, no problem. Okay, looking at -3. This value, remember, is our k value. And all that's going to do is move everything down 3 spaces. So there is our second one. Kind of sketch that one on there, just so you have a little bit better idea what we're looking at. The next one is the green one there. Remember, when we're inside the bracket, we are doing the opposite. So it says -3. We'll go to the +3. Throw our points on there. Ooh, point of intersection. Look at that. Look at that nice little point. Whoop, missed the line. Mr. Shaw, just looking at the point of intersection, getting excited. Our last one here, if you look at it, had -3, so I multiplied all the up values by -3. Now, these aren't going to clearly fit onto our chart, but that doesn't mean that we can't actually still use them. So we got 0, 0. What do we got? Over 1, down 3. Oh, that's a really hard color to see. That's better. Nice and big. Over 2, down 12 would be kind of in this neck of the woods. And then when we connect them, kind of looks like that. It's really narrow. There. So that's the dotted line. Okay. Alrighty. Moving along. So just to recap all of the transformations. So how does this compare to this? Well, the A value tells us the sign of the opening, or the direction of the opening by the sign. Positive would be up, negative would be reflected down. If the A value is greater than 1, it's a vertical stretch by A. If the A value is between 0 and 1, it's a vertical compression by A. Remember, the sign doesn't matter. It can be -1 billion or -0.5. We would still have a stretch or compression. We always multiply the up value of our over and up chart by this value. H tells us the x value of the vertex. It's our horizontal shift. And K tells us the y value of the vertex. It's our vertical shift. Alright, so graphing this little section. So y equals x squared again. You should be able to do that, no problem. Start at 0, 0, over 1, up 1, over 2, up 4 in both directions. Plotted on. Boom, you're done. Looking at this one, I would move the vertex +4, because remember we always go in the opposite direction, and down 7. So I'm going to go over 4, down 7. Whoops. And I'm going to have my point. After that, I'm going to look and see, do I have anything here? Because that's going to change my over and up chart, and I don't. So I can just kind of connect the dots. Now let's look at our vertex. Our vertex is +4, -7. Remember, your axis of symmetry always comes from the x value of your vertex. This is clearly opening up. it's a minimum value because when I go down here I get to a minimum point. So it's a minimum value of my y value of my vertex. Always all real, and that underline isn't actually supposed to be there yet, but look at that. Y equal to or greater than -7, because it can only get down to -7 and it's a real number. Next, looking at this one. Now again, y equals x squared quickly goes on the graph. The 3 there is going to just move again. Oh no. Nuts. Let's do that. So the graph's already there. So I had to do my over and up chart. I multiplied all my ups by 2 because I had a 2 there. The 3 moved me 3 to the left. And there's the other point. That's disappointing. Oh well. Notice that the 2 makes the graph skinnier, as you guys are saying, or more narrow. Okay, it's stretching it up. It's taking all of these points and stretching them up. So really, I've only got 5 points for each of these graphs. And you'll notice that this graph, all of the points that we're looking at here, this one, this one, this one, this one, and this one, have all just been stretched up in that yellow graph. They're pulled up, so the graph's being vertically stretched. Finally, if I look at something like this, a lot going on here, but it's actually really easy to graph. Okay, this tells me to go -5 and then down 5. Okay, this tells me my over and up chart. So I put my standard over and up chart down, and then I multiply everything by 0.5. Now we'll graph this one just stating everything. So we've got our vertex, -5, -5. That gives us our axis of symmetry. The direction of the opening is down because of the negative sign. That makes a maximum value, and we always use our y value from our vertex. Domain is always all real. And our range is always our y value of our vertex. Ooh, Mr. Shaw's made a mistake here. I know you guys would catch me on that. But this should be equal to or less than. I hope that doesn't mess you up. Because the graph is facing down, so y is never going to be greater than -5. And my graph's right there. Okie dokie. So you're going to work on page 222 again, 3, 4, 5 BCD, 6 BCD, and then graph the following graphs here. Make sure you have good scales. That's the most important thing. I want you to have 5 points for all of these. Include 5 points. Ponds. Okay, so you need to be able to make scales that will include 5 points for all of them. I've tried to make a couple of them a little bit more difficult. This is just saying 2/3 or 1/3. It's just hard to write it on this program. Okay.